cities claim to have different proportions of residents who commute by bicycle. In City A, 42 out of 300 randomly selected residents commute by bicycle, and in City B, 55 out of 280 randomly selected residents commute by bicycle. Test whether the proportions differ at the alpha equal 0.10 significance level. Okay, so what kind of test is this? We're definitely talking about proportions, and they actually gave us two sets of proportions here. So we have a two proportion z-test. All proportion tests are z-tests, so it's definitely a z-test. And when we go to put this in the calculator, we're going to use the two prop z-test. Okay. So things that we need from up in the problem, they gave us 42 out of 300 for our City A scenario. So our X1 is 42 and our N1 is 300. In our second scenario, they gave us 55 out of 280. So our X2 is 55 and our N2 is 280. And so your proportion, you're going to have a P1 that's 42 over 300, and you're going to have a P2 that's 55 over 280. And remember, to make sure we're allowed to do these tests, we need to make sure that the N times the P and the N times the Q for both of them is at least 5 or greater. So I'm going to take that 42 over 300. That's giving us 0.14. That's my P, and this will be my P hat 1 because this is our first proportion. I'm going to multiply that times the 300, which is the N value, and make sure we get above 5. We totally do, so we're good to go for that. So the 0.14, in order to get the Q, I have to do 1 minus 0.14, and that's going to be my Q hat sub 1. So I get 0.86. We're going to multiply that times the N1, which is 300, and we definitely got more than 5. So our first proportion is good to go. Second proportion, we're going to take the 55 divided by the 280, and this is our P2. 0.19, or we could make this 0.2 if we wanted to round up a little bit, but I'll just take that value and multiply it times the 280 and make sure we get above 5. We got 55, so we're definitely good there. And then if I round that to 0.2, then 1 minus 0.2 is going to give us the Q sub 2. So the Q2 is 0.8, and we're going to multiply that by the 280, and we got way more than 5. So second proportion is also good to go for us to use the two proportion z-test. So you always want to check that your P times your N and your Q times your N for both proportions is 5 or bigger. So we've checked that. We're good to go. Our null and alternative hypotheses, since we're talking about proportions, I'm reading again, and it just says test whether the proportions differ. Doesn't say one's bigger than the other. So our null and our alternative hypotheses are just going to have an equal sign and a not equal to sign. So null hypothesis is that P1 is equal to P2, and the alternative hypothesis is that P1 is not equal to P2. Okay. Test statistic. We're going to get that from the calculator. I know it's going to be a Z because this is a Z test. And then we'll also go find our P value from the calculator. So we want the two proportion Z test for this one. Two proportion Z test, we go down to number 6. And it wants me to enter in my X1. So my X1 we said was 42. They want my N1, we said that was 300. They want my X2, we said that was 55. And they want my N2, we said that was 280. And it's going to be just the not equal to for the alternative hypothesis and calculate. Okay, so we've got our Z, which is negative 1.82 approximately. And then our p-value is 0.0688 if I stop there. Okay. So again, when you're looking at the output for this test, you'll see a P and then you have a P hat 1 and a P hat 2. Those are the two numbers that we got when we took like we took our X1 and we divided it by the N1. That gave us the 0.14. And then when we took the 55 and divided it by 280, that gave us the 0.196. So don't confuse those when we're looking for the p-value. We want the p-value that's directly below the z that they give there. So our p is not particularly small in this case. And so if we go back up and we look at what the alpha is for this one, we're hoping it's a high alpha if we're still wanting to be able to reject. And actually, our alpha is a 10% alpha. And so because this is 10 pennies and this is more like 7 pennies, yes, our p is still smaller. So because we got a pretty high alpha, we're still okay here. So our p value is smaller than our alpha because our alpha was a pretty big one. So we are going to reject the null hypothesis. And so if we are rejecting the null hypothesis, then we say there is sufficient evidence in this case at the 10% level to suggest. And then we go back to what we said in the alternative hypothesis, that there's a difference between those two proportions. So the proportions were between the two cities, city A and city B. So we'll say there is sufficient evidence at the 10% level to suggest that the proportions of residents Bye. Who commute by bicycle differ for each city. Or for the two cities would also work. Okay, so again, because we were rejecting the null hypothesis, we come up here to the alternative hypothesis and we say there is sufficient evidence to suggest that there's a difference between these two proportions. So there is sufficient evidence at the 10% level to suggest that the proportions of residents who commute by bicycle differ for the two cities.